Welcome, class 10, chapter matrix and determinant, solving linear equations by matrix method. Solving linear equations by matrix method. We have already learned in compulsory mathematics solving of simultaneous equation based on two variables. So linear equation, here we are going to study solving of linear equation by matrix method. We can solve linear equations involving two variables by different methods. We have already learned in compulsory method in class 4, 5, 6, 7, 8, 9, 10 and higher class also will be learning. That is, we have already learned in junior classes by substitution method, by elimination method, by cross multiplication method, now matrix method, graphical method, and determinants method. Okay, so we'll be learning by more and more methods. So here this question previously used to ask of 4 marks in SLC examination. Now this is solving of linear equations by matrix method. So I am going to take two linear equations involving two variables x and y. Let the two linear equations be a1x plus b1y plus equals to c1 and a2x plus b2y equals to c2. These are two linear equations that I am taking, and now I would like to solve and I will show you how to solve. Now this is theory, so pay attention over here. Now this again I am repeating, and we are reading solving of linear equations by matrix method. This is, we are taking two linear equations based on or involving two variables, that is x and y. So we are going to solve this. Let's first of all, these two linear equations are given to us. Let's express them in matrix form because we are going to solve by using matrices. Okay. So expressing the above linear equations in matrix form, we have, let's express. So after expressing in matrix form, we will get a1, a2, coefficient a1, a2, b1, b2, xy, and this c1 and this c2. Okay. If you express this two linear equations in matrix form, then it will come in this form. Now your question is how this comes in this form. The question is how these two linear equations can be expressed in this form. So let's go back. Let's forget about. Now you understand. Let's multiply this first of all. Let's see how it will happen. If I multiply, these are two matrices. It's of order 2 by 2 and it's of order 2 by 1. And this is order 2 by 1. If you multiply this matrix, what you will get? You will multiply this one, so you will get a1x plus b1y. And down you will get a2x plus b2y. This is a matrix after multiplying. You will get a matrix of 2 by 1, and this side also, that is c1, c2. Now if you will equate, these two matrices are equal matrix. Now if you equate, then what you get? a1x plus b1y is equal to c1. That is a1x plus b1y equals to c1. One equation you will get. And a2x plus b2y equals to c2. You will get next equation. So when you multiply this, you will get this results, and equating you will get the same equations. That means this equation can be expressed in matrix form in this way. So expressing these equations, this can be converted into this form, then this also can be converted into this form. So these are the linear equations, two simultaneous equations in two variables, involving two variables x and y, and I am expressing these two linear equations in matrix form, and this is its matrix form. comma, which is in the form Ax equals to B. It is in the form X. A is also a matrix, this matrix, X is this matrix, and B is where A means A1, A2 and B1, B2. A means A1, A2, X means XY, and matrix B means C1, C2. C1, C2. It is in the form, this is in the form X equals to B, where A is equals to this and B, X equals to this and B is equals to this. Now, to solve these linear equations by matrix method, first of all we need to check we need to find the determinant of this. So let's find the determinant of this, and therefore determinant of matrix A will be equals to A1, A2 and B1, B2. Cross multiply. The result is A1, B2 minus A2, B1. A1, B2 minus A2 by B1. Let's assume that this is not equal to 0. Now we have two conditions. If the determinant of A will be equal to 0, then what will happen? And if the determinant of A is not equal to 0, then what will happen? Let's assume that this determinant of A equals to, not equals to 0. Now, I will talk at last. If this becomes equals to 0, then what will happen? Now we consider that there is some value. This value is not equal to 0. So, since determinant of A is not equal to 0, so A is a non-singular matrix and A inverse exists. That is, since A is a non-singular matrix, determinant of A is not equal to 0 and A is a non-singular matrix, that's why it is possible to find A inverse. So that's why A inverse exists. Now let's find what is A inverse. And therefore, now A inverse is equals to 1 by determinant of A dot adjoint of A. What is 1 by determinant of A? That is A1 B2 minus A2 B1. A1 B2 minus A2 B1. And what is the adjoint of A? The principal diagonal element changes. That this becomes B2. This is sign and other minus sign changes. This minus sign changes and diagonal element is. This becomes A1. Okay. This is value. This is, now you multiply inside. You will get its A inverse. Okay. This is A inverse. This is A inverse, but this is not A inverse matrix. So you need to multiply inside. You multiply inside and you will get A inverse. So you want to do that, then you will do, but B2 by, that is A1 B2 minus A2 B1. Okay. Then minus B2 by B2 by 2 B2s. How 2 B2? Okay. This is not B2. This is B1. This is B1. Okay. Then that is B1 by A1 B2 minus A2 B1. Okay. This is minus A2 by A1 B2 minus A2 B1. Okay. This is A1 by A1 B2 minus A2 B1. Okay. This is matrix A inverse. Actually, we are not. It is not necessary to find here because we are reading theory. So, though we have found, okay, no problem. Now, since we know that Ax equals to B, it is in the form X equals to B. So let's pre-multiply both sides by A inverse. So now multiplying both sides by A inverse, we get, let's multiply. So A inverse AX will be equals to A inverse, okay, A inverse, it is B, A inverse B. Now this can be written as A inverse A times X is equals to A inverse B. This is associative property of matrix multiplication. That is, A times BC will be equals to AB times C. AB times C. It is a property of matrix multiplication. So you can write this, and you can write this. Okay. Multiplying both sides. So or this will be result. This will result to identity matrix IX is equals to A inverse B. Since this is also the properties of matrix multiplication. That is, if you multiply any matrix by its inverse, either positive multiply or pre multiply, अगाडि multiply गर्ने or पछि multiply गर्ने, त्यसको inversely, then the result is an identity matrix of same order. So we have already studied in class 9 also, and in class 10 also in the beginning we have studied this is, that is A inverse will be equal to A inverse A is equals to identity. This is a property. This is a property of matrix multiplication. So finally we have A inverse A is results to an identity matrix. Okay. Now again this is X. Is equals to A inverse B. How this is X? Since if you multiply any matrix by its identity matrix of same order, the result is that matrix. So here I is the multiplicative identity matrix. That is, we have read this also. This is also in the property, matrix multiplication property. That is, if you multiply any matrix by the identity matrix of same order, that is, we have already said that AI is equals to IB is equals to, AI equals to IA is equals to matrix A. Yeah, these conditions we have studied. This is matrix multiplication property, and whether it is AI or it is IA, the result is matrix itself. Here I is the identity matrix of same order as matrix A. So here I is called multiplicative identity. Because if you multiply any matrix, that matrix identity one will lose, and this is multiplicative identity. So here Ix will be equal to X itself. Ix will be equals to X itself. So this is our final conclusion. So at last, what we have got? Here we have got two matrices. One is matrix X and another is matrix A inverse B. You multiply these two, you get a new matrix, that is A inverse B matrix, and you have X matrix here. You equate both these matrix components of matrix, you get the value of X is XY, X is XY, X is XY, and A inverse is you get the values. You get the value, and by equating this, you get the values of X and Y. So here to get this, you can say by equating the corresponding components or elements or objects or components of equal matrices X and matrix X and matrix A inverse B, we get values of X and Y. We get the values of X and y. So in this way, when you get these values, two variables x and y, this equation can be solved. So now the condition is, now this is its theory. So in this way we will solve every problem, every matrix problem, simultaneous equation problem. In this way, this is a procedure of solving the simultaneous equations involving two variables. Involving two variables. Now the question is, now what I have said, the determinant of a, how do you know this is 0 or not? Here I have assumed that this is not equal to 0. If this is not equal to 0, then this is possible. If this becomes 0, then what will happen? If a determinant of a is equal to 0, suppose if determinant of a will be equal to 0, then what will happen? Then if determinant of a equals to 0, then it will be 1 by 0 dot adjoint of a, 1 by 0 is infinity dot adjoint of a, then what result you will get? Nothing. You will get nothing. So that's why. If determinant of a is equals to 0, if the determinant of a will be equal to 0, then there is no solution. This case of if the lines are parallel, if the lines are coincident, then they will have the same equations. They will have the same equations over here, and the ratio of the coefficients will be the same. So that's why you have no solution. You have no solution. That means the determinant of the matrix A here will be equal to 0. When the determinant of matrix A is equal to 0, A becomes a singular matrix and A inverse does not exist. When determinant of A, when lines are parallel or coincident, determinant of A, the determinant of A will be equal to 0. When determinant of A is equal to 0, A is a singular matrix. A becomes a singular matrix. When A will become a singular matrix, A inverse does not exist. So you have no unique solution in this case. So that's why for solving this simultaneous equation by matrix method, that determinant of A must not be equal to 0. Must not be equal to 0. So this is the case. This value equals to 0 and this value not equal to 0. If not equal to 0, you will get a solution. If equals to 0, you are not going to get the solution. So let's do problem. I will take some examples and I will solve this. Now problems. Now let's go to the problem. You can leave this as it is. Over next. Okay. Okay, start by solve the simultaneous. Solve the simultaneous equations. Solve the simultaneous equations. X minus 2y is equals to minus 7 and 3x plus 7y is equals to 5. X solve the equation 5. Okay, let's solve. This simultaneous equation involving two variables we are going to solve by matrix method. Let's write. Given equations are x minus 2y equals to minus 7. Equation 1. And next is 3x plus 7y equals to 5. Equation 2. Okay. Let equation 1 and equation 2. Here what you have to mark is that if any equation like 3x plus 3y, 2x plus 3 minus 3y plus 7 equals to 0, if there is like this, then the first thing that you have to mark while solving this simultaneous equation by matrix method, this constant term must be taken into right hand side. So 2x minus 3y equals to minus 7. Here the constant terms are itself given, both the constant terms are given right hand side, so there is no intention. If in question the constant terms are not in right hand side, your first duty is to take the constant term on the right hand side and make the equations. Okay. Now in second problem I will take that constant term right hand side, left hand side into right hand side. I will convert and I will show you here. Now see, this I assume these two equations. These are two equations in one. That variables x and y. Let's express. Okay, expressing the above equation in matrix form. We have coefficient of right 1, 3, minus 2, 7. This is x, this is y, minus 7 and 5. Okay. Already I have explained how this comes here. If you multiply this and equate, you get the same equation. So this is expressed in the matrix form. Okay. Now, comma, which is in the form x equals to b, comma, where a is equals to here 1, 3, minus 2 and 7, comma, x equals to small x and y, because matrices are denoted by capital letters, so here I am using the capital letters. X and b is equals to minus 7 and 5. B is equals to minus 7 and 5. Okay, let's go. So, let's find, and now let's find the determinant. So therefore, determinant of A is equals to how much? 1, 3, minus 2 and 7 cross multiply. So it becomes 1 into 7 minus 3 into minus 2 is equals to 7 plus 6 is equals to, the answer is 13. Answer is 13. You write here. Since determinant of A is not equal to 0, so A is a non-singular. A is a non-singular matrix. A is a non-singular matrix and A inverse exists. A inverse exists, and also the above system of linear equations, and also the above systems of linear equations have unique solution. It has a unique solution. So we have found determinant. Now let's find A inverse. So here only I will find A inverse. Okay. Let's go. So 1 by, the value is 1 by, so 1 by, the answer is, what is the determinant of A? 13. It's 13. The matrix is adjoint. Adjoint of A means principal diagonal element change. A, what is A? This becomes 7, this is 2, this becomes minus 3, this is 1. Okay. So you can take this. So 7 by 13, 2 by 13, minus 3 by 13 and 1 by 13. Okay. Here. Now we know that since Ax equals to b, we know that x equals to b, or x will be equals to A inverse b. From theory we have already said this theory, if x equals to b, then x will be equals to A inverse, we can write as A inverse b. Or what is x? X is xy is equals to, what is A inverse? So A inverse, don't write this value. If you write this value and if you multiply with matrix B, it will be a complicated solution. It will be very difficult for you to multiply. So don't take this. You take this one. You take this value. Okay. So A inverse means I will take this one. At last I will multiply 1 by 13. 1 by 13. This is 7, 2, minus 3 and 1. And what is matrix B? Matrix B, you know, it's minus 7 and 5. Okay. Is equals to 1 by 13. So first row into first column, multiply. 7 into minus 7 plus 2 into 5. Okay. Minus 3 into minus 7 plus 1 into 5. Okay, is equals to 1 by 13 minus 49 plus 10, and this is 21 plus 6. Okay, is equals to 1 by 13 minus 39 by, this is 5, 26 will be equals to, this will go inside, so minus 39 by 13 and 26 by 13, or x and y, this means x and y is equals to how much? Xy is equals to, this value is minus 3 and 2. Yes, this value is minus 3 and 2. That is x equals to minus 3 and y equals to 2. This is your answer. So in this way we solve the simultaneous. This is the procedure. In this way you need to solve in examination. If you solve in this way you get 4 marks. So this is the procedure of solving the simultaneous equation by matrix method. So we are getting the value of x and y, two variables, there are unknown variables x and y. So let's take next example. Let's take next example here. Okay. Now your book question number 2. Question number 2. Okay. Solution. Okay, it's a solution. The given equations are, 3x minus 5y minus 3 is equals to 0. If 3x minus 5y I see equal to 0, then this implies that this is 3x minus 5y equal to 3. In question it is given this, but I have to clear, to make you more clear, so I have made a question this one. So you write this way, this is equation 1. This is equation 1. And next equation is that your 4x plus 3y, 4x plus 3y is equals to 4. Okay, this implies that, so not 4, let us take minus 4 equals to 0. Then this is 4x plus 3y is equals to 4. Let's make this equation 2. This is equation 1 and this is equation 2. Okay. Here I am trying to show that if constant term is left hand side, then you will take on right hand side, both the constant terms or both the equations. Now let's express them in matrix form. So I am writing here. So WRI, writing the above equations in matrix form. We have let's write in matrix form. Put here 3, 4, and this is minus 5, 3, 4, minus 5 and 3. This is x, this is y, and this is 3 and this is 4. Okay. Comma, which is in the form, ax equals to b, which is in the form x equals to b, where a is equals to 3, 4, minus 5 and 3, comma, x is equals to xy and b is equals to 3 and 4, 3, 4, b is equals to 3, 4, okay, 3, 4, correct. And let us find a determinant of a is equals to 3, 4, minus 5 and 3, 3 into 3 minus 4 into minus 5 is equals to 9 plus 20 is equals to 29. It's 29. Okay, no problem. Right here, since determinant of a is not equal to 0, so a is a non-singular, so a is a non-singular matrix, and A inverse exists. And also the above system of linear and also the above system of linear equations have unique solution. So determinant of A is not equal to 0, so A is a non-singular matrix, A inverse exists and the above system of linear equations have a unique solution. You will get the unique solution. So let's find now. Let's find what is A inverse. What is A inverse? So it is 1 by 29. So adjoint of A adjoint of A is diagonal element change. It is 3, it is 3. It is minus 5, it becomes 5. It is 4, this is also 4. This becomes minus 4 and this is 3. Okay. You want to write A inverse exactly what is the value of A inverse you want to find? Then it is not necessary. So you want to find, then you find. It becomes 3 by 29 is 5 by 29 minus 4 by 29 and 3 by 29. But we are not going to use this value. We are going to use this value while solving the equations because it is easy for us. So let's go. Let's solve. So here I am drawing this. Here. Yes, now we know that x equals to A. Since x equals to A, x equals to B, so x will be equals to A inverse. You can write this one. So x comma y, x value is x comma y. So what is A inverse? So what is it? 1 by 29 and it is 3 minus 4, 5 and 3. And then what is the value of B? What is the value of B? B, matrix B is 3, 4. 3 and 4. Now let's multiply. It is 1 by 29. So 3 into 3 plus 5 into 4 and minus 4 into 3 plus 3 into 4. Okay. So 1 by 29. It is 9 plus 20 and it is minus 12 plus 12. So it is 1 by again 29 is 29 by 0. So it goes like this. It is 29 by 29 and it is 0 by 29. Or xy is equals to the value is 1 and 0. That is x equals to 1 and y equal to 0. This is our answer. You can write therefore the value of x is, you write therefore the value of x is 1 and y is 0. Therefore the value of x is 1 and y is 0. This is our answer. That is x is 1 and y equals 0. So I have solved. In this way you solve all the problems of simultaneous equation. More now, what type of variety you get in this solving of simultaneous equation by matrix method, that also I am going to discuss. Now just you see this one. I lose the time. Okay, no problem. Now, yes. Okay, the time duration here now is 38 minutes. Now we have more time. Let's do. Let's start. No problem. Okay. Now let's talk about the variety. What type of questions may come? So I will drop this one and I will say so. Now here I will show. Okay. Okay, first I will show in my own style. Now you try to understand. First one, the question is simple question. One number is the question is simple question. One. First one you will face the simple question. The constant term is right hand side. Okay, no problem. The first one, let's say one question will come like 2x plus 3y. This is example. Okay, I am taking 2x plus 3y equals to 5 and 3x minus 17y equals to 18. Okay, this is an example. This question, both the constant term here is on right hand side. We don't have any problem. Okay, this is one variety. Go for the next variety. This. It may be 2x minus plus 3y minus 5 equal to 0 and here is 3x minus 17y is equals to, if they give like this, minus 18 minus 17y equals to 0. If they give like this, then you take constant term right hand side and you arrange this one. So here you need to arrange. You will take the constant 2x plus 3y is equals to 5 and here 3x minus 17y is equals to 18. You will arrange in this way. You take both the constant term on the right hand side. Okay, this is next one. Now third one. Now they may give you like this. What? X. It is x by 2 plus y by 3 is equals to 5 and x by 7 minus y by 8 is equals to 11. Okay, like this question. Both the, you see, this is the same form. This means there is nothing. While arranging this in matrix form, it seems like your mathematics. What will happen? If you solve this, if you express in matrix form, then it is x by 2 means what? This means half x, like 7x, it is half x. So when you arrange this in matrix form, so you do simply. So what happens if you arrange this in matrix form? If you arrange the coefficients, so it will become half. This will be 1 by 7. This becomes 1 by 3. This becomes 1 by 8. And this is x. This is y. And this is 5 and 11. So you write the coefficients. You write this is 1 by 2, 1 by 3, 1 by 7, and 1 by 8. So minus 1 by 8. X and y. So in this way we arrange in the matrix form. While expressing this in matrix form, you write in this. There is no problem. Simply during calculation you may have some difficulty. Otherwise, everything is same. With this up. Now go for this opposite case. 4 number. Now if I revise 2 by x plus 3 by y is equal to 4 and 7 by x minus 8 by y is equal to 9. Yes. Here both variables are denominator. Here both variables are denominator. Then how do you solve this? To make it more simpler, you can do like this also. Directly also. Otherwise, if you want to make, here I will show you both the ways. Suppose what to do? This means 2x means what here? 2 by x means what? 2 by x means 2 times 1 by x. 2 times 1 by x. And 3y means what? 3 times 1 by y. So here you understand, right? And how do you express this in matrix form? It's very easy. It's 2 coefficient is 2, coefficient is, here is 7, here is 3, here is minus 8. And here, what is the law of air? Here will be not x, it is 1 by x and 1 by y. Is equals to, now it is 4 and 9. Suppose you do, if you don't want to do in this way, then you can assume it and you can make it more simpler, and last you put the value, you get the answer. How? Here I am explaining it. Suppose these equations I can convert in another form also. By example, if I assume 1 by x as x dash and 1 by y as y dash, both above, both below. Okay, second case. So 1 by y, what will do? This equation will turn in this form. 2x dash, because 1 by x is x dash and 1 by y as y dash, then this equation will be 2x dash plus 3y dash is equals to 4, and this will become 7x dash minus 8y dash equals to 9. So now if we arrange, in matrix form, then it is very easy. It is 2, 3, 7 minus 8, and here instead of 1 by x there will be x dash and this will be y dash. So you go on solving, where will the problem? Here will come the problem. Here will be x dash and y dash. So first you put here x value is x dash, y dash, and second step when you come here you put 1 by x and 1 by y, and then you get the answer. Suppose value of x, x is equals to x dash and y dash is 2 and 3. Then what is x dash? X dash is 1 by x and this is 1 by y is equals to 2, this is 3. So now we equate. So value of x will be 1 by 2 and the value of y will be 1 by 3. So we get in this way. I will solve this problem again. I will take some examples. So if you come like this and you solve in this way. Now go for next. Now, fifth number. They may give x above and y below. Like example, x by 2 plus 3 by y is equal to 7 and x by 7 minus 3 by y equals to 8. This also can be expressed in matrix form. How do you express this in matrix form? So 1 by 2, 1 by 7, this is 3, this is minus 3. Okay. And this is what? This is a numerator is x and denominator is 1 by y. 1 by y is equals to 7 and 8. Okay, this you can arrange in this way in matrix form. This is arrangement of the simultaneous equation in matrix form. Oh, sir, I am getting confusion. Then you convert this 3y. 3 by y is equal to 3 into 1 by y. And suppose this 1 by y as y dash. So this will be x plus y dash. X also you suppose x dash. Let x be equals to x dash. So finally this equation will be converted into which form? This equation will be converted into this form. So this equation will be converted into this form. If you do this one, then this you can write half x dash, x as x dash, and plus 3y dash, 3y dash. 1 by y equals to 1 by y. Y here is equals to 1 by y. Y dash equals to, understood, it is 1 by y is equals to y dash. So what will happen? Half x dash plus 3y dash will be equals to 7 and 1 by 7 x dash minus 3y dash equals to 8. So you will get the value of x dash will be x only and the value of y dash is what is that? That is 1 by y. At last here you solve. So here will be the value of x dash is x and the value of y dash is 1 by y. You put the value, you get the answer again. You equate both sides, you get the answer. So nothing is confusion here. So you express this one in matrix form. Okay. Go for next. Okay, this is one next. Go for next. This x is above. Similarly, there will be the case of x both above, x and y both variables below, denominator place. Here x is above, y is below. Now here may be 2 by x plus y by 3 is equals to 5 and here is 7 by x minus y by 2 is equals to 8. Okay. Here we have x in numerator place and y in denominator place. Here we have x in denominator place and y in numerator place. This is above, this is below. Here now x is below, y is above, okay, numerator. So it is the same. Now you express in matrix form, what you get is nothing here. It is 2, 7, 1 by 3, 1 minus 1 by 2. Here is 1 by x and y is y. Okay, it equals to, it is 5 and 8. So you can assume here 1 by x as x dash and y as y dash. And then last you put the value, you get the same answer. There is no any confusion here. Okay, there is no any confusion here. Go for next. Okay. Now you may get questions like 3x plus 4y by 7 is equals to 5x minus 2y equals to 3 is equals to 1, like this. Then from here 3x plus 4y this will be equal to 7, you will get one equation, and 5x minus 2y this will go that side, it will be another equation. So you solve both the equations. And next one is by what? Language problem. Last one is there is language problem. We have a language problem. We will solve that problem also. Now let's do some 2 or 2 problems, and I shall clear your confusion here regarding this variety. So you may have this type of variety. There is no any problem. You solve this one all here. I am going to solve 1 or 2 problems. So yeah. Okay. Okay, here. Just you see. One problem. Okay, then question number K. Question number K, N and P I will solve. K, N and P. Okay. K number question. It's very easy. Solution. The given simultaneous equation are the given simultaneous equation are 2k x plus 3y equals to 5, and next is 4x minus 9 by y is equal to 6 is equals to 6. Like this, let us convert by here. Okay, here first equation, so okay, no problem. Then these two equations, and next equation is 4x minus 9 by y is equals to 6. Okay, two equations we have here. Let x is equals to x dash and 1 by y equals to y dash. Let x equals to x dash, then the equation becomes, then the above equation becomes, this will change into x dash plus 3y dash is equals to 5 and 4x dash minus 9y dash equals 6. This is equation 1 and this is equation 2. That equation will turn into this form. That equation will turn into this form. Now let's solve. Writing expressing the above equation in matrix form. Okay. Expressing the above equations in matrix form. Expressing the above equation in matrix form, we have expressing the above equations in matrix form. We have, what do we have now? We have x dash coefficient. Let's write first of all 1, 4, 3 minus 9 x dash y dash is equals to 5 and 6. Okay, now let's find comma which is in the form ax equals to b, comma where a is equals to 1, 4, 3, 6, not 3 minus 9, comma x is equals to x dash y dash and b is equals to 5 and 6. Okay, and therefore let us find determinant of a. What is determinant of a? It is 1, 4, 3 minus 9. Just you cross multiply 1 into minus 9 minus 4 into 3 is equals to minus 9 minus 12 equals to minus 21. It's minus 21. Okay, x minus 21. Right here. Since determinant of a is not equal to 0, so a is a non-singular. A is a non-singular matrix and A inverse exists, and also the above system of linear equations have unique solution. Also the above system of linear equation have unique solution. Let's find A inverse, and therefore A inverse is equals to 1 by determinant of A adjoint of A, 1 by minus 21 adjoint of A, change minus 9, minus 3, minus 4 and 1. We just keep this much only, let's not multiply inside. If you like to multiply, then no problem. Okay. Minus 9 deposit side, it becomes 3 by 7. 3 by 7 minus 1 plus 3 by 7. It becomes 1 by 7. This becomes 4 by 21. This is 1 by 21. Okay. Okay. Now we know that since Ax is equals to B, or x equals to A inverse B, or x equals to A inverse B, or x equals to A inverse B. So what is x? X is x dash, y dash. What is A inverse? A inverse, take this value. Don't take this one, it will be difficult. So you take this value. So 1 by, so minus 120, minus 1 by 29. What is matrix? Minus 9, minus 4, minus 3 and 1. Okay. What is B? Matrix B is 5, 6. 5 and 6. Let's multiply this and check. So how much? 1 by 29. Let's multiply. Minus 9 into 5 plus minus 3 into 6 minus 4 into 5 plus 1 into 6 is equals to minus 1 by 29. 9 4 is 45, minus 45 minus 18 minus 20 plus 6 minus 20 plus 6 is equals to minus 1 by 29. This is how much? This is 27. 27. So not 27, sorry, this is minus plus. So 63. It is minus 63. This is minus 14. Okay. Okay. Now this goes inside. This goes inside, minus minus becomes plus. Both is minus, so it becomes plus. One value is 63 by 21, another is 14 by 21. 14 by 21. Or x is what? 1 by x. 1 by, sorry, x dash is simply x. X dash is simply x, and y dash is how much? 1 by y. So don't write here, you write here. Next line you write, or this means x and this means 1 by y. Now the value is 3 and 2 by 3. 3, 2 by 3. So by equating both sides you get, therefore value of x is 2 and value of y will be equals to 1 by y equals 2 by 3. So y will be equals to how much? 3 by 2. Change. So the value of y is 3 by 2. So this is your answer. This is your answer. Okay. See, this is your answer. Okay. In this way you solve. Suppose, sir, I don't want to solve in this way. Then what to do? Then don't do this. Not compulsory. No need of this. Suppose this itself as equation 1 and equation 2. Okay, you write this here. This is x and this is y, sorry, 1 by y. Okay, no problem. So here will be also x and 1 by y. Okay. Others are same. Only here is what? This is x, this is 1 by y. So now equate. You get the answer, same answer. Now equate, you get the same answer. Without assuming. If you don't like to assume, then no problem. You get the same answer. There won't be different in answer, only the slightly procedure changes. So everything is same. Everything is same. What time? Let me see now. 4 problems I need to do more. Okay. Now it is almost 1 hour video. So now more 2 or 3 varieties I will show, and language problem also 3 problems more I will show, and this solving of simultaneous equations by matrix method will be completed. Good. Now I will give you the questions. Suppose you want to write the questions, then you go to the last of the video, see the questions, write the questions in your copy first of all. Then you see these all videos, you will understand. It will be easy for you to do. Now I will give you the questions of exercise. Okay. So your homework is exercise 3.2. all you solve with the examples. This one you solve all. Now okay, here. Okay, now come to the your problem of books problem. So here I am showing with the photo. Please, this is okay. Now this side Okay.